Let's continue our study of factoring, and I'd like to remind you of the flowchart that I've given you in advance. And that flowchart says that you should always start by factoring out the greatest common factor, hereafter called GCF, greatest common factor. So please, I'm going to sound like a broken record, and my flowchart that I've given you has a broken record on it, and it's because of this. After that, what you do next is you count the number of terms in the problem that you're trying to factor or write as products. If there are two terms, it is either the difference of squares, which is what we're going to focus on in this video, or the difference or sum of cubes. And so the flowchart probably looks a little bit different than this, but it's got something about difference of squares and difference or sum of cubes. If it's got three terms, that's kind of the involved problem. And from there, we're going to go with two offshoots from that. One is going to be where you have a trinomial, x squared plus bx plus c, but the big thing is there's going to be a 1, and therefore nothing written in front of the x squared term, versus there's going to be a number in front of the x squared term, a 2, a 13, a 24, whatever, and that's a little bit harder. And then finally, we're going to concentrate on factoring something with 4 terms. So after we've counted the number of terms, we go look and see if there's 2, if there's 3, or if there's 4, and we follow the appropriate processes. This one we're going to factor by what's called grouping. That will be after this next video. But let's go ahead now and look at a continuation of, this is going to be factoring with 2 terms, and I apologize, my worksheet was numbered wrong on my document that I just pulled up. So this is number 4, number 5, number 6, 7, and number 8 at the bottom. And I just want to remind you, see this problem right here? I want to remind you that when you take a binomial x plus 5 and multiply it by a binomial x minus 5, those are called the sum and difference of like terms. And when you multiply these together, x times x is x squared, but this outside factors in the foiling process and these inside factors of 5x, they cancel out because they always add to be 0. And then finally, the last term is always going to be a positive times a negative, and in this case, a minus 25, like this problem right here, x squared minus 25. So if you have, please remember, it's got to have a minus sign in the middle for it to be the difference of squares. If this is an even exponent, and if you can take the square root of that number, or for that matter, the square root of the number in front of the x squared term, if you can do that and get a whole number, then you have what's called the difference of squares. And there's really not much process to it. You'll put an x in the front of each of these binomials because their product is going to be the x squared, and you'll put a plus 5 in one and a minus 5 in the other. It does not matter what order. It could be the minus 5 in the first and the plus 5 in the second. But if you FOILed that out, you'd get the x squared minus 25. Let's do another one that doesn't have a coefficient in front of the x squared term. So let's just do x squared minus 81. So the square root of 81 is 9. So you would factor this into an x plus a 9 and an x minus a 9, and you're done. Remember, because this times this will give you your x squared term, and this times this will give you your minus 81, and the minus 9x and the plus 9x we don't care about because they combine to be nothing. So in number 5, what is the square root of 9? Yep, that's 3x. So you'll put, I'm sorry, just 3, but you'll put a 3x in the front of each of these because their product will be 9x squared. What's the square root of 49? Yep, that's 7. So a plus 7 in one, a minus 7 in the other. Again, please remember, it could be the minus 7 first, and it could be the plus 7 second. So next, number 6, stop. Do not do. This does not work for the sum of cubes, because if you tried to factor this, and maybe put a plus 7 here and a plus 7 here to get that positive 49. Yeah, you'd get the 9x squared, but you wouldn't get rid of this 21x and this 21x. I mean, yeah, you'd get the 49, but you wouldn't have the original problem. So this problem is prime. It is not factorable. So this is called the difference of squares, a subtraction sign, not a plus sign. The next problem. 81 minus z to the fourth. It doesn't matter what order. This has got a minus sign. The square root of 81 is, please put that first. Don't try to rearrange this problem. It's too challenging. The square root of z to the fourth is z to the second, because z to the second times z to the second gives you z to the fourth. So what I would have here, a plus z squared in one of these and a minus z squared in the other. So if I have the difference of squares, this just has to be an even value for me to factor it, because I add these exponents and they have to be the same, and 2 plus 2 is 4. Be careful. The 9 is a perfect square again. This one has to be factored again. Just the one in red here has to be factored again, because the square root of 9 is 3. And then I'd put a plus z in one of these, a minus z in the other, because of this minus z squared. Remember, that one cannot be factored. And finally, we are done. We've got our full factorization of 81 minus z to the fourth power. Let's go over here to number 8. Yeah, remember my monotone. That's what I was trying to take out the greatest common factor first. So please, when you go to take out this 3, don't do anything else. Just write the 3 in front, and if you distributed this, you'd have 3x to the 8th and 3y to the 8th. Now, these are even exponents, and there's a minus sign. So I can factor those into x to the 4th, because I'm multiplying these. And when you multiply, you add 4 plus 4 to be the 8. And then I would write these as y to the 4th. Oops. So a minus sign. Bring down my 3. Oh, dang. This has got a minus sign. It's got to be factored again. And I'd need in the front of each of these binomials an x to the second power, because when I add those exponents, I get a 4. I like to put my plus sign first and then my minus sign, because I'm going to bring all this down so I don't lose it. In case I can factor again this x squared minus y squared, which I can, it is the difference of squares. I like to do that at the end. So I'll put an x in the front of each of these, a plus y in one, a minus y in the other, and then I am finally done, because I don't have a difference of squares at the end. The exponents are x to the first. Right here, x to the first and y to the first. So they're not even. The rest of these are all plus signs. So finally, I am done. Okay, let's look at this. This is called the difference of squares, and I can take the square root of 16. You could just think of this a plus b, you could just call it the letter u. Sometimes we do that. We call a plus b the letter u squared, and then minus the 16. But if u represents a plus b, when I'm all done, I got to put the a plus b back in place of u. This is challenging for some people. Some people like instead to, because now what I do is I'd factor this into u plus 4 and u minus 4, and then in place of u, I'd substitute a plus b. So in place of this, I'd substitute a plus b and bring down my plus 4. And right here, I'd substitute a plus b and bring down my minus 4. And I'm done. That is the factored form of this problem. If you can instead see this as just x squared, you could go right to opening two sets of parentheses and saying to yourself, I got to put an a plus b in the front of each of these. I'm putting them in parentheses so that you can see that that's a plus b times a plus b, which is a plus b squared. Then stick a plus 4 in one, a minus 4 in the other, and you're done. And these parentheses weren't necessary at all, because here was my answer, and this is the same answer. So I don't need those parentheses. On the other hand, when I do number 12, I could go ahead, if you don't mind, I'm going to open up two sets of parentheses and put an 8 in the front of each of those because the square root of 64 is 8. In one of them, I'm going to put a plus sign, and the other one, I'm going to put a minus sign. And inside the parentheses, I'm going to put p plus q, because p plus q times p plus q is p plus q squared. However, over here, it matters. The minus sign is in front of this binomial. So when I clean that up and get rid of this set of parentheses, the p becomes a minus p and the q becomes a minus q, and now I'm done. So I've added, besides some really simple difference of squares problems, I've added some really challenging problems. And if you would now, after having watched this riddle, I'm looking to see if or watched this video, I'm looking to see if I have some difference of squares problems. There are a few, and so I must admit that it's page 87, the riddle that's called "Why Doesn't a Gyro Bet on Even Numbers?" I will just tell you that on that worksheet, in order to practice a little bit of difference of squares, but there's also greatest common factors. Number 1, I'll just put commas. Number 3 in that worksheet. Number 5, number 6, number 9, I believe is difference of squares. I got to check. Yep, I think so. And probably number 12 on that riddle. If you would try those videos now to get some practice, and then come back and watch with me our next segment, which is factoring something that has 4 terms.